Welcome to the STEM Pathways with Rohan Sharma podcast, where we dive into the exciting world of science, technology, engineering, and math. In each episode, we share exciting stories, groundbreaking research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Ari Noori, who holds a bachelor's and master's in computer and electrical engineering from UW-Madison. How are you doing today?
Doing well, man. Glad to be here.
Yeah, so to get started, I wanted to ask what made you choose your major in the first place and what were your interests back in high school?
Yeah, that's a great question. So, I work right now in something called quantum computing, and we can talk a little bit more about quantum computing later, but effectively, what it is just a new way of doing computation. It allows us to solve problems that are not previously solvable on normal computers. And so, all the way back in high school, I graduated high school in 2019. And all the way back in high school, I was in this physics class taught by a really great physics teacher called Mr. G. This was AP Physics C. And Mr. G really was a quite inspiring physics teacher. And I'll tell you a little anecdote. The first physics class, first physics test that I took in that class, I actually got an F. And then I asked him, I was like, oh, can I please retake it? Can I please retake it? And then I studied really hard. I got an A, and then I got A's only for the rest of that class. But anyway, Mr. G was very inspiring in physics. And I knew that I always liked computers. I built computers when I was younger. I always tinkered with computers, tinkered with electronics, just around. I would actually dumpster dive, at electronics recycling places to extract computer parts and like build computers out of those. And so I've always been interested in computers and technology. And then when I took this physics class, I really was inspired by that teacher to, continue learning physics. And I became knowledgeable about this, or at least informed about this topic called quantum computing. And I thought it was very interesting. I thought it combined a lot of my interests, and I thought that it would be a way to have a very positive impact on the world through advancing science and technology that is so cutting edge. Um, and so, with that, when I went to UW-Madison as well, as you are going to, Rohan, um, I chose computer engineering as my major because it seemed kind of like the most logical choice given my interest in computers and hardware and electronics. And so at the time, kind of as a freshman going into it, I had this notion that I wanted to work in quantum computing. However, what I saw at the time was that most people who worked in quantum computing had PhDs and their background was in pure physics. And I knew I didn't want to do pure physics. I was interested in physics. I liked kind of the more fundamental side of things. I liked learning physics. However, I know that I didn't want to be a physicist, and nor did I really want to get a PhD at the time either. And so I thought this whole quantum computing notion was very intractable for me because I didn't have the right profile. But little did I know that quantum computing actually needs a lot of people like me who hold master's degrees in engineering in order to make it practically useful for the world. So eventually, I kind of was doing my computer engineering coursework, and I realized that UW-Madison had good opportunities in quantum computing. There's a lot of research labs, and I went on a whim to take classes that I didn't need to take for my computer engineering degree, which were more on the quantum side, learning some more quantum physics, modern physics. And then once I was taking those classes, I was again really inspired by the professor, really enjoyed the class, and then started getting more opportunities in in the quantum computing field. So I'll stop on the quantum computing. I want to answer your question, like, why did you choose your majors? I chose computer engineering, honestly, because it fit my kind of interests going into college. And then I pivoted for my master's degree, which is actually kind of more in electrical engineering versus computer engineering, even though the same department, more emphasizing electrical engineering, because I realized that the skills that I needed to work in quantum computing were less on the computer engineering side, at least for what I wanted to do, and more so on the electrical engineering side. But let me just say this: like electrical and computer engineering is probably the most powerful engineering major because electrical engineers can pretty much do anything. Like there's a lot of electrical engineers who then will specialize in biomedical engineering, or then specialize in mechanical engineering, or some sort of combination of all of these things. And so electrical engineering, I think, gives you the broadest exposure to everything in engineering. So it's like kind of the safest bet to go for. If you're interested in engineering and you like electronics and technology, it's definitely the safest bet to go for. So that's kind of why I chose those fields. I was always interested in kind of technology, computers. And then as I was going through my educational career, I found that electrical and computer engineering allowed me to hone my education in a way that was very purposeful for me to build a career eventually in quantum computing.
Wait, so how early again did you realize that you wanted to go into quantum computing? Was that back in high school or?
Yeah, that was in high school. I was like, I thought that it was, I thought it would be cool. Like honestly, at the time, I didn't know that much about it. I thought it'd be really cool. I wanted to contribute to something that I thought would have a positive impact on the world, and I wanted to continue. I wanted to be some. I wanted to work on something that was cutting edge, right? Um, and so it was all the way back in high school that I kind of incepted the notion of wanting to work in quantum computing. But I guess I had this kind of like I had self-limiting beliefs definitely like as a freshman and even a sophomore before I started kind of getting more experience in learning more about quantum and getting in a research lab and stuff like that, that it wouldn't be possible. So it was always kind of like a dream, I guess, all the way back into high school. And then eventually I worked really hard to kind of make it reality right now.
Yeah. So going in your freshman and sophomore year, obviously like computer engineering isn't an easy major, and you had
Sure.
pretty good grades while you were doing it. Is there anything you think that you did that a lot of other people don't do that helps you do that?
Oh, yeah, that's a great question. So the problem I think that a lot of students face when they're trying to study or they're trying to do work is they're very distracted. And it is so powerful if you can literally just like turn off all the nonsense, turn off your phone, don't be distracted, and just do 2 hours of studying. Like what'll happen is um like I would witness a lot of people, they'd be at the library, they'd be like working, right? They'd be in groups. And then everyone would just be like chatting for maybe 40% of the time. And then 30% of the time was like them on their phones or something else. And then the rest of the time was studying. So only a small proportion of that time that they were at the library was actually studying or doing work. So what I think allowed me to get good grades was twofold. I knew how to focus and I knew how to actually like dedicate time to being focused and getting work done. And then the second thing is I really did rely on other people in the sense that I would go to review sessions with the TAs. I would go to office hours a lot and get things explained to me. Like I'm not some genius person. Like I'm not one of those people that like just takes the test without studying and gets a really good grade. Or I'm like not one of those people that just like takes the ACT or the SAT and gets a perfect score. Like I know some of those people. I'm not one of those people. Like it takes me a long time to get stuff. I need to sit there and actually study and really work through it. And oftentimes, like I wouldn't get something right away. And but at the end of the class, or like at the end when the test came around, I would have the best understanding out of anyone in the class because I would work really hard to figure it out. I would go to the professor, I would go to the TA, or I would work with like other smart people, motivated people in the class to work together and help each other. Like so, like working on homework with people in like a productive way is very very helpful. We would do my friends and I we would do a lot of like asynchronous stuff where we'd like be working on the homework like at the same time, but we would not be in like the same room. We'd just be like texting each other every once in a while. Okay, like I did problem five, like I'm stuck on this part. What did you do for this one? They would send me, what they did, and then I would understand it now after seeing what they did, and then I would internalize it and that kind of stuff. So kind of circling back, how do you get good grades in college, especially like if you're doing something difficult? Well, you need to not get distracted. You need to dedicate time to actually doing your homework or studying or whatever. And when I say dedicate time, I mean just like put your phone away. Don't screw around on your phone. Don't open up YouTube. Don't open up some nonsense on your computer. Like literally just set a timer for like 1 or 2 hours and just grind it out. That was the best way. Just deep focus, really. Number two is utilizing the resources of the TAs, the professors. And then number three is kind of like being very mindful and productive when you're actually working with other students and utilizing the other smart, motivated people in the class. So who you hang out with and who you talk with in the class is really important. Don't waste your time with like somebody who's going to bring you down. You don't need to be rude or disrespectful, but like if you find that day one you're sitting next to people who are distracting you and who aren't like motivated to get good grades or aren't motivated to do well in the class, then you don't need to sit by them anymore. It's plain and simple like that.
Yeah. So something I wanted to ask you about is what people should focus on when it comes to extracurriculars going into college. I've heard some people say don't even like think about them until your second year because you should just be focusing on school right away. And then other people who literally have every club and research and lab planned out but like the summer before they even get into college. What do you think about that?
So I think research is definitely something you should do at some point. Um, let me, I guess, start from the beginning. So for me, the extracurriculars that I did, I regret not doing more. And so the last semester of my bachelor's degree and then going into my master's degree, I started a club. I started the quantum computing club, and that was honestly one of the most fulfilling things that I ever did because it was really engaging to kind of not only lead the club but just be a part of something that was beyond school. And so looking back on my college career, I would have wished I would have done more extracurriculars in that sense. And not just extracurriculars for the sake of, advancing your career or gaining a new skill, but like stuff that's also fun as well. So I would say that what you should likely do in terms of extracurriculars is don't overload yourself when you're a freshman, but be willing to try a bunch of different things when you're a freshman and then hone in on like the handful of extracurriculars that you actually enjoy. So I think the notion of not doing any extracurriculars and just focusing on school is a mistake. You definitely should do extracurriculars when you're a freshman, not only to build a social circle, but to like round you out. And honestly, dude, the extracurriculars, whether it's like robotics or whether it's playing volleyball or whatever, those kind of experiences are still beneficial when it comes to building your career because it helps you develop, charisma and social skills and speaking skills, or helps you think outside the box and not just like what you're doing on a daily basis, like, physics or math or engineering classes. So I would say that to start as a freshman, do extracurriculars that are not super time consuming. Try a bunch of them and then kind of hone in on which ones you actually like. And then when you start getting some more experience, like maybe you're going into sophomore year, try to get in a research lab. Research lab is most definitely incredibly beneficial, not only because it helps you understand academia and how academia works, which is very different than how industry works, but it also gives you some tangible and practical experience in your field. And even if it's like some biology lab that is kind of loosely adjacent to what you want to do, just the experience of working in a lab is not only good on your resume, but just good experience for you. Then one comment I will make, I don't know if you consider this an extracurricular. I guess I do. I always had a job while I was in college. So my first job was working as like tech support for the libraries, all the different libraries, they have computers. And then like we would have the student help desk where somebody would submit a ticket like, oh, my computer's broken. And then I'd go walk over there and like help them fix it. So if you consider that an extracurricular, I kind of always had an extracurricular. And I think that having a job, it forces you to manage your time better, even if it's like 5 hours a week. I think I worked at most like trying to think. At most, I worked like 15 hours a week or 20 hours a week. It wasn't a ridiculous amount of time. Some semesters it was like 10 or 5. But always having a job while you're in college helps you manage your time and then helps you prioritize. It helps you prioritize what's really important to you and what's kind of going to drive you forward. It also keeps you like from just wasting a lot of time. Because quite frankly, like you can get your schoolwork done really fast. If you can work efficiently and figure out the systems that'll help you get your schoolwork done, you're gonna have so much free time compared to everyone else, and you're gonna want to fill that with something productive. So that's my recommendation. Try to get a job. If it's something useful, like doing tech support. Obviously, I'm not doing tech support now, but just kind of loosely adjacent to technology, somewhat helpful. It was good skills, good kind of learning how to interpersonally relate with people and help people. That was good development. Definitely do something fun, have some extracurricular that's fun, and then try to get in a research lab. And then a research lab, I would count that as working because more often than not, the research lab will actually pay you money, which is good. Um, so yes, extracurriculars, great. Do as many of them as you feasibly can, and then really hone in on like the ones that you find important for your life and you actually find interesting.
So, what were some of the first extracurriculars that you did?
First one that I did was getting the job at the library, if we call that, an extracurricular. Then I did at some point, I started doing karate, which was honestly really fun. But then COVID happened. So COVID happened the first semester of my freshman year. The second semester, the spring semester of my freshman year. So I only had like one real semester before COVID blew everything out of the water. And so at the time, I was doing, I was working that job. I was doing karate, and I played like intramural sports here and there, just like volleyball and basketball. But those were kind of the two things that I did as a freshman. And then COVID happened, and so that kind of like stalled everything out for the next year and a half. And then when I got back from COVID, that's when I started working in the research lab. And that was, there was a period when the only kind of extracurricular thing I did was work in the research lab. There was also a period when I was taking like straight STEM courses that I didn't even have the prerequisites for. Like I was really grinding during kind of that like junior year period. So the only extracurricular that I did was lab work. And then finally, like towards my senior year and then through my master's degree, I started that club and that used a lot of my bandwidth, but I found that very fulfilling. So that was kind of the evolution of my extracurriculars. And there, like you said, there's a lot of people that do like 100 extracurriculars. I think that you should only do the extracurriculars that are actually valuable to you. Like, don't just like pad out a resume. I think that's the dumbest thing. When people pad out a resume just with stuff and nonsense to make it look better, like people can read through that super easy, especially at like, you know, high tech firms with like really high performing individuals. Like they can read through all that.
So, one thing people talk a lot about when it comes to research is how to get the research in the first place. Do you have any advice for what people should do once they're actually in a lab?
Once they're actually in a lab or when they're trying to get a lab experience in the first place.
Or like once they actually get the position?
Oh yeah. Well, once they actually get the position is going to be, totally dependent on what, the PI wants you to do. Some PIs, when I say PI, principal investigator, that's like the guy who runs the lab, the professor that runs the lab. Sometimes you're never even going to talk to him and you're just going to work with the grad students or the postdocs, which is totally okay. Sometimes they're going to be very free and just pretty much give you the opportunity to contribute wherever you need. Sometimes they're going to give you grunt work that's really boring, but just needs to get done. At the end of the day, like you should listen to, especially in the beginning, you should listen to what they want you to do, impress them, and then with time, you'll be able to gain more agency over what you want to do in the lab. Especially because if you just get to a lab, you might not understand what you're actually interested in contributing to. And so for me personally, like the first, so I was working in a quantum computing lab. I got a research experience in a quantum computing lab, neutral atom quantum computing. And the first task that I was assigned with was build a box, basically an experiment enclosure that was temperature regulated and radiation shielded, right? So not like explicitly related to quantum computing, but just kind of adjacent to the infrastructure surrounding the experiment. And I honestly thought that was a cool project. I got to have a lot of agency over it. Like he was just like, okay, here's your task, deliver it, right? They didn't tell me step by step what to do. And that's what was very fun about that. So basically the evolution was, okay, Ari is joining this lab. I'm going to assign him with this graduate student who needs some help. And then the grad student told me like, okay, we need somebody to build this experiment enclosure with these requirements. Can you do it? And I was like, yeah, let's do it. And then from there, like I spent, I think 2 years in that lab or 2.5 years in that lab, maybe a little longer. Then from there, like once I showed that I could deliver a project and I could work on my own and learn stuff on my own, then I started suggesting to the professor, I said, okay, can I contribute to this project? I want to get closer to the actual quantum computing. Can I contribute to this project? He said, yeah, of course. Let's talk to the postdoc and see what makes sense. And then, my projects evolved from there. So I would say that if you're getting research, uh, don't don't jump around labs. I know there are some kids that try to like min max their lab experience and like get like 5 different labs, but at the same time, you're not really learning anything because there's that like first project that may or may not be that applicable to what you want to do, and you still are kind of like figuring out what the lab does. If you can build kind of depth and stay in one lab for at least a year, then you might be able to get more fulfilling projects. But ultimately, it's going to come down to like what the PI wants you to do. But once you can show the PI that you can actually do stuff, then you can start taking more agency over what you do and what you choose to do in the lab.
Yeah. So, something else you did is you started this quantum computing club. When did you do that, and what kind of things were you able to do with it?
Okay, so the reason why I started that quantum computing club was because I had struggled really hard going from, just engineer, right? Just engineer, right? Into getting internships and getting experiences in quantum computing. Quantum computing is a field that historically is very dominated by physicists and people with PhDs. And that culture is shifting because we actually need to build quantum computers that are, scalable, big enough, and practical to run useful quantum algorithms. And while we, of course, will always need the people with PhDs and the deep physics background, we're going to need people to actually build this and build the infrastructure around it and how to control a quantum computer, right? And so those are all the things that are gating the ability for quantum computing to be practically useful for the world. And so the culture and the skill necessity is very much so shifting in the industry, but the like job progression and the resources out there are still lacking at this moment. So what I realized is I went through a lot of trouble like trying to get an internship at IBM when I was younger. I went through a lot of trouble getting that research lab position. Like I got rejected or actually ghosted, and not even rejected, ghosted by like every single professor that I emailed. And then finally, like I had my physics professor at the time, like send me like a recommendation, like, hey, this student is like the top student in my class right now. Like he's really interested in your lab. And then I immediately got the response back. So thankfully, like I was able to get into that lab and kind of start my quantum computing journey. But I had struggled so much, like getting into the lab, then getting an internship and all that stuff. And I wanted to help students who are interested in quantum computing learn how they can start to build their career. Because the problem with the quantum computing education right now is it's still focusing on that like physics aspect of it, this quantum algorithms aspect of it, this theoretical aspect of it that is not, like, in my opinion at least, the most important thing towards building an actually useful quantum computer, right? We need to basically make quantum computers bigger. We need to make them more scalable. We need to increase the number of qubits, right? So a qubit is just something that it's analogous to a normal bit in a quantum computer. We need more qubits, right? And the way that we do that is, yes, of course, through kind of physics evolutions, but a crucial part of it is also through engineering evolutions, right? We need people that are going to design the infrastructure around a quantum computer that's going to allow us to scale it up, that's going to allow us to control and read data from them with, really high fidelity. And so there's this kind of other aspect to quantum computing that is equally as important, if not more important, in my opinion, that there's almost like no support for. And so what this club served as was a way to support the students who were like engineers or who were software developers, software engineers who wanted to work in quantum computing, but like had no idea how they could contribute because all they see is like physics and complex math and matrix algebra and stuff like that. And that's not all that quantum computing is. Quantum computing is a very broad field. And so I kind of used my knowledge and my experience of like going through it myself and suffering and like going through all the pain and of learning and failing and whatnot. And then kind of had that quantum computing club become a community of students who were interested in quantum computing and wanted to learn more about the other avenues and like how to build a career in it. And so I started that, I think, the last semester of my senior year, and then continued on through my master's degree. And I really focused on, developing foundational skills in quantum computing, like teaching people just the basics, like the most important information that they needed to know. I also wanted to give them a lot of like career advice, like how to get into a lab, how to get an internship, how you should be structuring your resume. You should be, how you should be developing your social skills, your communication skills, how communication is one of the most important things in engineering and science. And then additionally, like hosting hackathons. We did a partnership with IBM at the time where we did what's called the Qiskit Fall Fest, which is just a big event of education. And there was a hackathon at the end where students could, get some real, tangible experience in quantum. And so really what I wanted to do is just support the community of students and my friends and all those people that wanted to work in quantum computing, wanted to learn more about quantum computing, wanted to get more involved, but just like simply didn't have the resource. So when I say this was like one of the most fulfilling things that I did in my life, because I really felt that I was helping the people around me, and it was very purposeful work. I think I gained a lot from it too, because it helped me develop like my communication skills, my leadership skills. And I find it fulfilling because like there's a lot of students that I did give advice to and I did help that are now, doing really well. Of course that they worked really hard and put in the work to actually do it, but I feel good about like help guiding them towards getting some things done. So they take all the credit, of course, but just to be able to help the students and see the community growing and get a lot of students together in one place who are interested in quantum computing to support each other was very fulfilling. So if you have the opportunity to start a club or you have like a good idea, I would recommend it because the skills that you gain and fulfillment that you gain from doing that, I think is second to none, especially as a college student. It really just gives you a really great perspective and experience on the world.
So you were just talking about the club you started. We just ended and then restarted the recording. So you said you were able to get a bunch of people together who love doing quantum computing, which I'm guessing is kind of a niche topic, so that doesn't happen very often. Uh, a lot of those people, you said they're working quantum computing now. And then during college, you said you were also able to do internships in quantum computing. What kind of internships were those and what were you able to do? I guess when I hear quantum computing, it sounds like the most complicated thing ever. Were you able to do much actual work in it as a college student?
Okay, so I'll break down some of the things that you said there. We'll go through everything. So first and foremost, the club that I started was very much so catered towards beginners or people who just thought it was interesting.
Yeah.
And so while there were like a lot of people who came, there was on average maybe like 40 people that came to the club meetings every time, some less, some more. There was one club event that had like 90 people come. And not everyone was like super dedicated to working in quantum computing or anything like that, but they did have an interest and they did want to learn more. And that was, of course, totally welcome. I would say that a small percentage of the people who would actually come are now like working in a research lab or doing internships or doing a PhD in some sort of quantum computing field. And that's because, not everyone wanted to do that. Some people just wanted to learn from it. But to then answer your question about like, okay, how did I get internships? And then what did I actually do in the internship? Let me just go back and explain quantum computing very basically. So quantum computing is a new way of doing computation. It effectively allows us to use special properties of quantum physics in order to solve problems that are not solvable on normal computers. So it doesn't matter like how fast your computer is. It doesn't matter if it's the best supercomputer in the world. It also doesn't matter if the supercomputer is going to be a billion times faster than it is right now. There are problems that are just provably not solvable on a normal computer. A quantum computer, on the other hand, because it is able to use special properties of quantum physics, it's able to run algorithms or run programs that are different than normal computers and allow us to solve some of these unsolvable problems. And so this has a lot of applications for some more deeply scientific fields. One of the most kind of relatable ones is in the pharmaceutical field, where chemists and biologists can really simulate and calculate and understand what happens when certain molecules are interacting with each other. And the reason why that's a really good problem to solve on a quantum computer is because that's a quantum physics problem in the first place. And so maybe that sounds really complicated, right? So what did I actually do when I was an intern, and did I get to do anything? And so the great thing about quantum computing is, yes, it's very esoteric and challenging in terms of the physics and the fundamental science. But like I was saying earlier, we need to build quantum computers that are big enough and actually practically useful for the world. And the way that we do that encompasses a lot of other engineering challenges. And so what I focus on is, remember how I was talking about the qubit? The qubit is the fundamental unit that we use to do computation in quantum computing, analogous to a normal bit in a normal computer. And so in order to do any sort of quantum algorithm, you have to send data to and read data back from one of those qubits. And so you need some very specialized electronics and hardware in order to send data to and read data back from the qubits. And so what I work on, and what I worked on when I was an intern, and what I work on now, is how do we send data to and read data back from the qubits? Those are called qubit control electronics. And scaling the qubit control electronics, making them bigger, but also higher density, making them higher performance, those are all things that are very interesting physics and electrical engineering problems, but also very, very crucial for making quantum computing work in the future. And so when I was an intern, my first internship was at IBM Quantum in Rochester, Minnesota, where they focus on building the qubit control electronics that sit at room temperature, meaning that they're just like in server racks, like, connected via wires into the quantum computer. And so there, I worked a lot down in the lab where we were experimenting and developing these qubit control electronics. I would debug problems that they have. I would flash, the FPGAs to different versions and run tests. I would support, the firmware team, the software team, the people doing the signal integrity. I would run experiments and, measure the output of the electronics and make sure that they were performing as they should be. And then from there, I returned after that summer. I realized, oh wow, that is great. I love qubit control electronics, and that's my niche, right? That is perfect niche for me. And I didn't know any of that really existed until then, right? Because, like I said before, I had this. I was an electrical engineer, I was a computer engineer, and I didn't fit that picture of like, oh, I'm a PhD physicist, right? But then when I had that enlightening experience at that internship, I realized that, there's a lot of this engineering work, specifically with the control electronics, that is incredibly critical for quantum computing. And that was my niche, right? So then I kind of decided, okay, I'm going to graduate early from my bachelor's degree and start a master's right away, because I felt that I needed to gain more skills. And I really, at that point, knew what I wanted to hone my skills on. And so I did one more year of school, and then I did another internship at IBM, this time in the New York research lab in Yorktown Heights, the TJ Watson research lab. And that's where they have all like the quantum computers, and you've probably seen pictures of it online. That's where they have all that stuff in New York. And so now I was really getting closer to the quantum computer, getting closer to the qubits. And then in that summer, that was like an incredibly enlightening summer. I learned a lot. But the great thing about the internships at IBM, at least in my experience, was like I got to do real work, which was awesome. Um, what I worked on that summer was instead of the qubit control electronics, I actually worked on the way that we send those signals down to the qubits. And you might say, okay, that sounds really simple. Just hook it up with a wire, right? No, I mean, just hooking it up with any old wire is not going to work, because the wires can distort the signals and make them not good by the time they hit the qubits. One thing about quantum computing, at least what we do at IBM, is we need to have the quantum computers be really cold. And if something is an electrical conductor, like it conducts electricity, more often than not, it'll conduct heat really well too. And so we have to be very cognizant of the way that we design our wires, such that not only are they like making the signal maintain good, what we call signal integrity by the time it gets to the qubits, but we also can't make them transmit so much heat, right? Otherwise, we will, what I like to call, blow up the fridge, right? Blow up the quantum computer. So um, there's a lot of these really interesting physics and electrical engineering trade-offs that we have to make in order to kind of design these what we call transmission lines, which are what we use to send the signals to and from the qubits. And so now what I do, that now those two internships then culminated in my full-time job now at IBM Quantum, where I work again on qubit control electronics. Now this time, instead of the qubit control electronics being outside of the really cold refrigerator, they're now inside the really cold dilution refrigerator. And that has a lot of its own challenges, right? To be able to take something that's really big and really hot and then, shrink it down to the size of a quarter and put it inside a fridge. And so the experiences that I got from my first internship and my second internship have been like crucial in not only shaping what I went to go back and learn when I was, finishing my master's and my bachelor's, but also have been critical. Those skills that I developed when I was an intern have been critical to what I'm doing now as my full-time job. Now, let me make a caveat. The reason why I think I got value out of my internship is because I really went out there and grabbed the bull by the horns. Like I wanted to get some experience. I wanted to do something that I was going to learn from. And so I didn't just kind of sit back passively and tell people and let people tell me what to do or just wait for somebody to tell me something to do. If there was something that I wanted to do, I went out and I asked to do it. And I think that's really important for internships. The internship is not for you. The internship is not for the company. The internship is for you. The internship is for you. Yes, the company should theoretically get some good work from you. But honestly, I think more often than not, the company just pretty much tosses out whatever work that you did that summer. Because it's really just like a hiring and a training pipeline. That's really what an internship should be, is that they are effectively interviewing you for 3 months or however long your internship is, and seeing if they like you, seeing if you have good skills, and then also trying to teach you some of those skills at a discount, basically, when you're an intern, so then you can maybe eventually come back full time. And so realistically, I would prioritize your internship on your learning. And if there's something that you want to do, go out there and grab it because nobody's really going to tell you no. I mean, there's stuff that like I got told no because there's like a lot of confidential stuff with quantum computing and they don't want, some random intern knowing it. But um, more often than not, when I ask to do something, people are like, yeah, let's go do it. So you have the agency, right? When you are an intern, you have the agency to be able to at least ask to do something that you want to do and really take the advantage to gain the skills that you want to gain during that experience. So I think that answers your question. Did I leave out anything?
I don't think so. So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or college wanting to follow a similar career path as you.
So similar career paths, specifically to quantum computing, I'll talk on that. If you are in high school right now and you want to work in quantum computing, you kind of have to figure out, which path you want to take. And the first path is kind of the traditional path, which is the physicist, kind of the deep scientist, and that is generally going to require a PhD. And so, what does that path entail? That path entails some of the more complicated math. That path entails some of the more complicated physics, like how do we design a qubit, or how do we fabricate a qubit? Those are some examples of like kind of the deeper side, or if you're interested in something like quantum algorithms, like if you like the math, right, then quantum algorithms can be something that is going to be a good career path for you. But you also have to acknowledge that you will be taking on a lot of schooling burden, right? Because those things require a PhD. Not only are you going to have to go through your bachelor's degree, but more than likely, if you want to work in these kind of very esoteric and kind of mathematically and physics challenging fields, you're going to have to get a PhD, which is like an additional 5 or 6 or 7 years on top of that. Um, but that's okay, right? I'm not saying any of that is bad. If you're interested in it, pursue it, right? Because the most important thing I think for a high schooler is gaining experience to figure out what you like and what you don't like. Don't do anything that other people tell you to do. Just do what you actually genuinely want to do. Okay, so that's like path number one, the traditional path where you get a PhD to go to quantum computing. What's the other path? The path that I took? Well, it's identifying a place where you can apply what you're interested to quantum computing or the ecosystem around quantum computing. So I'm interested in electronics, computers, electrical engineering. And so what I did is I found a niche, which is control electronics, that helps support quantum computing and send data, read data back from the qubits. And that's perfect for what I'm interested in, which is electrical engineering. But you may be somebody who wants to work in quantum computing, but you really like writing software, or you really like working with Raspberry Pis or embedded systems or something like that. What you can do is you can continue developing those skills. So like go to college for whatever engineering makes sense, continue tinkering with Raspberry Pis and Arduinos, and then you can become what's called a firmware developer for quantum computing. Like all these control system stacks, right? They need somebody to sit there and write the firmware for them. And so path number two is basically figuring out what you like doing, what kind of like genuine technical skill you like doing, and then figuring out how you can apply that to quantum computing. So it's kind of two steps. Figure out what you like doing, then get really good at that thing that you like doing, and then learn a little bit about quantum to figure out how you can then apply what you like doing to quantum. And what's great about quantum is it needs so much infrastructure and it's such an interdisciplinary field that pretty much anything that you can fathom that you like doing or you're interested in, you could apply to quantum computing. But kind of the overarching theme of my advice is you first have to really figure out what you personally like doing, not what your parents want you to do, not what your friends want you to do, not what you think makes the most money. Like, figure out what you actually enjoy doing. And the way that you do that is you gain experiences, right? So just continue getting out there, trying stuff. Don't just stay in your bubble. Try stuff, extracurriculars, join a lab, get a job, take a class you're not supposed to take a class that you don't have the prerequisites for, take a class that's outside of your field, and then you'll start to gain some experience and really understand what you like and what you don't like.
All right, then. Thank you for joining me on the podcast today.
You're welcome. My pleasure.